Okay, hello everybody, what's going on? This is Mohammed, welcome to another video. In this video, we have two cylinders that are filled partially with water. So we have a vertical cylinder on the left-hand side. The height of the water is 10 centimeters and the remaining length is 30 centimeters. So the height of the cylinder is 40 centimeters. The radius of the cylinder is unknown. Now what we did, we have bent this cylinder by an angle of alpha, as you can see on the right hand side, and then that generated or created the lengths y and x. So the question here is to find y minus x, the difference between y and x, y minus x. So if you're interested, pause this video, give this problem a try, and once you're ready, keep watching this video for a solution. Okay, so to answer this question, what I'm gonna do, I will try. Now the idea to solve for y minus x is basically by benefiting from the fact that the volume of the water in both cases is the same. So what I'm gonna do, I'm gonna calculate the volume of the water in the left hand side cylinder and equate that with the volume of the water in the right hand side of the cylinder, which is a way. There's different ways which I'm gonna be exploring in this video. Okay, so let's draw a cylinder, which is, a bent rectangle. So this angle here is basically alpha, which is unknown to us. Okay, now that would, the level of the water would become like this. So let's make it a little bit lower. Okay, so this length here is x and this length here is y, and this is basically the water in the cylinder. Okay, so the volume of this water is basically the same in both cases. Okay, so this is the water. Let me just highlight it quickly. Okay, so this is the water. Now, if I connect, this line here, that would be also x here. And if I connect this line here, that would be also y. So the remaining length here is basically 40 minus x minus y. Okay, now the volume, the volume of the cylinder on the left-hand side is basically the area of the circular base multiplied by the height, which is 10 centimeters. So let's assume that the radius is basically a. Okay, that's unknown to us, but let's assume it a. So the volume is going to be what? Is going to be the area of the base, which is by a squared, multiplied by 10, which is the height. So that's the volume of the water. The volume of the water on the right-hand side is basically going to be this volume, which is nothing but pi. So the volume, let me highlight it in yellow, for example. This part here is going to be what? Is going to be again, the area of the base, which is by a squared multiplied by the height, which is x, plus now the remaining volume is basically going to be half this whole cylinder. Okay, so what I'm gonna do, I'm gonna subtract half pi a squared, which is the area of the base, of the circular base, multiplied by the height, which is nothing but 4 minus x minus y. And then I will divide both sides by pi a squared. So that's gonna delete these things here, pi, from both sides. And what we're gonna be left with is 10 equals to x minus half multiplied by 40 minus x minus y. And then what I'm gonna do, I'm gonna multiply both sides by 2 to get rid of the half there. So that's gonna give us 20 here, twice x minus 40 plus x. No, this is a plus, This is a plus. Okay, so the volume of the water is the volume in the lower part plus the volume in the upper part. Okay, so it's 2x, yes, plus, this is plus and this is minus, I'm sorry. Let me do it again. Okay, so 2x plus 40 minus x minus y. Okay, so 2x minus x, so that's gonna give us what? 20 equals to 2x minus x, that's x minus y plus 40. So if I move x minus y to the other side, it's gonna be y minus x. And then if I move 20 to the other side, it's going to be 40 minus 20, which is nothing but 20 centimeters. So that's a very simple way to solve for this problem, benefiting from the fact that the volume of the water did not change in both cases when we bent the cylinder by an angle of alpha. What we can do also a different way, so or alternatively, or simply, we can notice that the original height on the left hand side was 10, was decreased by a particular value. Let's assume it h. Okay, so so 10 minus h is going to give us x. Okay, let's number that as our first equation, and y was added by h, and that is going to give us 30. So that's going to give us our second equation. Now if we subtract 2 minus 1, then what we're going to get is that y minus x is going to be equal to 20 centimeters, and that is a very simple way to solve for this problem. Although I like the first method because it basically benefited from the fact that the volume did not change in both cases. If you like this video, hit like. And if this is your first time here, don't forget to subscribe to the channel and click the bell so you don't miss anything in the future. Thank you for watching, and see you in another video.